Hello my dear students, welcome again. In this class, we are going to study about the various characteristics of states of matter. We are going to know that on what basis different matter are divided into different categories, means classification of matter on the basis of their physical properties. So there are several classifications based on different properties, like we have already on the basis of conductivity. We already know that matter is divided into three different classes, and the three classes are metal, non-metal and metalloids. Like that only, there are several more characteristics on the basis of which matter is divided into three different states. Means the three categories are based on the physical states of matter, and the three physical states of matter are the solid state, the liquid state and the gaseous state. These three states are there. So basically I would like to tell you that what is the reason behind this classification. Why is matter divided into these three categories? The main reason is the arrangement of their particles and the variation of different characteristics of their particles. What kind of variations in characteristics? The first one is the arrangement, means the interparticle force of attraction, or we can say the interparticle space, means space between the particles of a particular matter. And the second one is interparticle force of attraction. And the third one is the amount of kinetic energy. The amount of kinetic energy the particles have. So these three, particularly these three points are the responsible factors for the classification of matter into these three states. The interparticle space between, what does it mean? It means what? The space between particles of matter. So what do we basically call a solid? Why a solid is different from other states of matter? It is just because it is rigid. There is a property of solid which is different from other two states of matter, which is rigidity. So rigidity basically means if an object does not change its shape, means it is rigid to maintain its shape. For example, see this marker. Even if I am applying some force on it, I am trying to bend it, I am trying it very hard to push it or compress it, but it is not being compressed, it is not being broken. Even if I am applying some force. So this paper is also a solid. If I am applying some force, but it is not being broken. So it has some shape. It also has some shape, definite shape, and it has a tendency to maintain its shape, which is called as rigidity. To remain in its own shape is called its rigidity. So different solids, all the solids have different shape and they have tendency to maintain their shape even if some force is applied. It is possible that some greater force may change its shape, but keep in mind that solids are rigid because it does not change its shape even on applying some small forces. Okay. Now the question arises is why does a solid has different shape? It is because its particles are arranged in a well-defined pattern and there is very small gap. There is approximately negligible gap among the particles of matter. Means particles of solid are very closely packed, as you can see in this figure. This figure shows what? This figure shows the arrangement of particles in a solid. You can observe that there are very less space between the particles and particles are not free to move. They can only vibrate. They are not free to move from their place. So this small interparticle space is due to what? This small interparticle space is because of very strong intermolecular force of attraction, or you can say interparticle force of attraction. Means the particles are closely bound to each other with a larger or with a stronger force of attraction. That's why they are very closely packed and there is very less space for the particles, and hence they are not moving. They cannot move from their place. They can only vibrate on their original place. So the first point, what is it? Interparticle space. If we talk about on the basis of interparticle space, what do we find in solid and what do we find in liquids and gases? We find that the interparticle space among the particles of a solid is very less. It is somehow negligible space is there. And if we talk about interparticle force of attraction, it is very strong. This is why this interparticle space is less, just because of this strong forces of attraction among the particles. And hence, since they don't have enough space to move, they can only vibrate about their mean position without moving from their position. They can only vibrate. What does it indicate? It indicates that the velocity of particles will be very much less, or we can say negligible velocity will be there. So there will not be any amount of kinetic energy there. So amount of kinetic energy is also very less in terms of solids. But on the other hand, if we talk about the liquid state, what do we see? This is a pattern for the arrangement of particles of a liquid. We can observe that the particles are somehow free, free to move about their mean position. They have not much space, but somehow they have a space to move from their place. So interparticle space is somehow greater than as the arrangement in solids. This is why? This is because the particles of the particles of liquids are not bound with that much stronger force as in case of solids, but this force of attraction among the particles of liquid is always greater than that of that of gases. Okay, so the particles of liquid have some kinetic energy, but not enough kinetic energy so that they can move freely in any direction. So since they have some kinetic energy, so they are having some characteristics of fluidity, means they can flow easily on a surface. So that fluidity, means ability to flow, comes because of this kinetic energy, and kinetic energy is possessed due to the greater spaces between the particles, and those spaces are because of the less we can say moderate forces of attraction among the particles. And in the case of gaseous state, what do we find? We find that the particles are very free to move. They have a large space among them to move in either direction, and hence they have more kinetic energy. Means they have kinetic energy the most in among these three states. So if you talk about the gaseous state, why are the particles separated with a long distance? This is because they have very less means they have very weak forces of attraction among them. They are attached to each other with a very less or we can say very weak forces of attraction between them. So they do not have any capability to bind other particles. Okay, so this is all about these three properties: interparticle space, interparticular forces of attraction, and amount of kinetic energy. And there are several other characteristics also on the basis of which we should know the differences between the solid state, liquid state, and the gaseous state. And what are those? See, since solids have since the solids have a particular pattern of arrangement of the particles, strong forces of attraction is there among the particles, so they have a definite shape. How can we understand that? I would like to take an example. See, if you put some stone in a container is there, and you put some stone or a solid substance into it, what have you observed? Can it take the shape of this container? No. Why? Because it is rigid. It has its own definite shape. So it does not contain the shape of the container, and it cannot fill this container. But instead, we would have used here some liquid, let it be water. Then what do we observe? We observe that it starts taking the shape of the container and starts filling the container. Means a liquid starts taking the shape of the container by filling it, but a solid do not. Solid never fills the container because it has its own fixed shape. So we can write here the solid state has fixed shape, and since it does not since a stone or a solid substance like book, marker, pen, paper, etc., all these are solids, so they do not fill the container or they do not take the shape of that container, because they have their fixed shape and they have their own fixed volume. But what about the liquid states? A liquid, when poured in a container, it starts filling it and taking up the shape of the container. So its shape is not fixed. If the container is changed, as per the shape of container, the shape will be changed. So it does not have a fixed shape, but with the volume of the container, we can find the volume of that liquid. So volume of this liquid is fixed. Whether the shape is not fixed, but volume is fixed for the liquid states. And what about the gaseous state? They do not have any fixed shape, nor they have fixed volume. Why? Because even a little amount of gas can fill up the container completely, and a large amount of gas can be filled up in the same container. So the volume of neither the shape of the gaseous state or matter in gaseous state is fixed, nor the volume is fixed. Okay. Now what about interparticle space? As we have already discussed, we can see from this picture that interparticle space is very less, or we can say that it is negligible. And this negligible space and this well-defined pattern of arrangement of particles gives it a definite shape. And for this it is also called as rigid. You have to ponder this point, rigidity. It is not mentioned here, but you have to consider this as the solid state is rigid. They have a property rigidity, but liquid and gaseous state do not have this property rigidity, means they are not rigid. So where we were talking about interparticle space. Interparticle space among the particles of solids is very less, or we can say negligible. But what about, we are since comparing this, so we can write it here that more than this but less than that. Hence the interparticle space among the particles of liquid is more than that of solid and less than that of a gases. So we can write it here as moderate, and here the spaces is very large space. Large spaces are there among the particles. Now it is what interparticle force of attraction. So you can easily say that interparticle force of attraction among the solid is very strong. And in the liquid state it is also strong, but not as that of the solid state. And here we can say very weak forces of attraction are there among the particles. Therefore they are free to move in either direction. See, since they are free to move in either direction, so they can flow easily in any direction. So they have a property to flow. So solids do not flow because they don't have kinetic energy. Particles cannot move. So solids don't flow. Fluidity means ability to flow. So we can write it here that solids do not flow or don't have fluidity, but liquids have fluidity and can flow easily. But it need always a surface to flow. Means it can flow from higher to lower heights. If it has to flow from lower to higher heights, means from bottom to top, if it has to flow, it needs some pressure. We are not talking this. We are not going to discuss this here. Now, gaseous state. In the gaseous state, they have very high amount of kinetic energy. So they do not have any. They do not need any surface to flow. They can flow from. They can flow without any surface in any direction. But it is to be considered that they can flow only from higher concentration to lower concentration. So they can flow easily. Now this word compressibility means what is compressibility? If an object or a matter does not change its shape or does not change its volume after applying a small force, then it is said to be not compressible. Means if it can change its shape, if it changes its shape after applying some force or after applying some pressure, and if it changes its volume, then a change in volume, then we can say that it is compressible. And if it does not, it is incompressible. So we can say that all the solids, see this is also a solid, and if I am trying to compress it, means I am trying to apply some force on it, it is not being compressed. Means there is no change in shape or size of this marker, and volume is, since its volume is fixed, so there is no change in volume. So after applying some force, there is no change in volume, so it is incompressible. And I have something to show you. There is an activity in NCERT, and according to that, we have to apply some. You can take a syringe. Sorry, yes, I have got it. See, how can you understand compressibility? How can you understand that a gas is compressible or not? You believe that air is a form of gas. Okay, it is a mixture of gases. So when I pull this piston downward, what happens? The air comes into it. Air is in, and now I am closing this knob. I am closing this end and trying to push this piston. While pushing this piston, what do I observe? I observe that I have to apply a greater force continuously. I am applying a greater force, and then it is very hard, it is very tough to push it after this. And when I release the force, what do you observe? You observe that the air which was compressed by the force applied by me, gets try to release its pressure and pushes the piston back. So air can be compressed. Air is from mixture of gases, so we can say that gases can be compressed easily because they have a larger space among the particles, and those particles can be made closer to each other after applying some pressure. Okay, for example, CNG gas or LPG gas, a large amount of gas is filled into a cylinder at a very large pressure. So the particles can be made close to each other on applying higher pressure. Similarly, since particles of liquids also have more space as compared to solids, so they can also be made closer to each other. So we say that the liquids can also be compressed, but the compression cannot be as much as that of the liquid state. So solids cannot be compressed. Why? Because they do not have enough space for the particles to make them closer. There is an exception in solids, like some sponge you find in pillow or seat covers, etc., and sofa. Those sponges have some air spaces, some spaces in them. In those spaces, air is trapped. When you apply some force on that, the air trapped into that spaces releases and shape is changed. And when you release the pressure, you release the force, again in those spaces air is trapped, and it again takes its original shape. So that is a kind of exception in solid state. But here we are talking about the compressibility of solid. Then we can say that most of the solids are not compressible. Liquids can be compressed but can't be compressed much. We say can't be compressed much as that of the gaseous state, and it can be compressed. Gases can be compressed very easily. Can be compressed easily. Now, the next point is what? On the basis of density. Density means solids have, see, a certain volume. Let the volume be equal. Means we have taken approximately the same shape of the three figures. Let us consider that this is an arrangement. This is showing an arrangement for the fixed volume. Means volume is fixed. So which of these three figures you find more dense? The most dense part of these three figures are this one, the solid, in the solid state. Why is it so? Because there are a large number of particles in a certain volume. Means if there is a large number of particles in a certain volume, it is called as more dense or dense area. So among these three, it is the most dense. It is denser than the gaseous state, and the gaseous state has least density. And density is defined as the ratio of mass and volume. Means mass per unit volume is called as density. And mass per unit volume means if volume is same, then density depends on what? Mass. And mass depends on the number of particles. Okay, so the more will be the number of particles, the higher will be density. So number of particles is the most in this figure, means in the case of solid. So the solids have solids are most dense, and the liquid has moderate density between the solid and the gases, and the gases have least density as they have very less number of particles in a certain volume. So we can say high density, solids have high density, they have moderate density, and the gases have least density. So in this class we have already known that how matter is divided into three states on the basis of variation in these three characteristics of particles and some other characteristics and properties of the different states of matter. Okay, hope you would have liked it. And in the next class we shall observe the effect of change of temperature and effect of change of pressure on these three physical states, and we shall come to know that whether these three states of matter are interchangeable or not.